When I was in middle school, I had a favorite math teacher who kind of liked me because I did, I guess I did the math well. But one time he was training us to memorize powers of uh, different numbers, like say 16 squared is 256 and stuff like that. Well, I was in Korea, so like that kind of mental math was part of the training, which is pretty good. I still appreciate it. Uh, but when it came to my turn, he asked me, "What is 2 to the 100th power?" Of course, I didn't know. But then I accepted the challenge and I tried to calculate 2 to the 100th power just with pen and paper. The computers weren't so available back then, and calculators they only give you 8 digits, and 2 to the 100 power is a 31-digit number. So trying to do that is quite hard. And I was able to do something like 2 to the 20th power with no problem. But then when it came to 100th power, that was like impossible. And so my best friend tried to help me out. So he got interested and he was calculating 2 to the 100th power. And after 1 month, we couldn't agree on the answer. So yeah, before I was able to use the computers to do the calculation, I had no idea what its exact value were. Okay. Uh, yeah, so now I'm telling you that story because right now this question is asking, you take this number 3 to the 100th power, and if you divide that by 7, what's the result? Yeah, it's already kind of ridiculous, right? However, we learned this modulo math, and that allows us to do such a calculation. So let me show you how that works. All the calculation afterwards are being done mod 7. Remember, uh, in mod 7, you can replace a number by another one as long as they have the same remainder after dividing by 7. So if you have 3 to the 100th power, that can be thought as 3 times 3 to the square to the 50th power, right? That's true without saying congruous, right? 3 squared to the 50, these two multiply, so it's same. And since they're equal as just regular numbers, they're still congruent under mod 7. But 3 squared is 9. And what is 9 mod 7? What's 9 mod 7?
2.
2. So you can replace 9 by 2. That makes it pretty easy, right? Okay, let's replace this by 4 to the 25th power, right? 2 squared is 4, 4 to the 25th power. And then, 25 unfortunately is not divisible by, oh, you know what? Here's a nice thing. 2 to the third power is divisible by, what's 2 to the third power mod 7? 2 to the third power is 8. 8 mod 7 is 1, just 1. Okay, so we're going to use that because uh, the first number that's divisible by 3, the nearest number that's divisible by 3, slightly less than this, is 48, right? So we can rewrite this as 2 to the 48 times 2 squared. These two add up, right? And then 2 to the third power, this is 3 times 16, so this is same as 8 to the 16th power times 2 squared is 4. And now you can replace 8 by 1, so it's 4. So the answer is 4. Okay. So we are able to find out this remainder without having to calculate 2 to the 30th power. Now, the fact that you can do such a calculation is one of the building blocks of the software security, of the internet security. So we will later go over the RSA security and Diffie-Hellman key exchange. All of them are built on the fact that you can take a number to a really high power, which by itself, I mean, this is, I don't know, that's like a 48-digit long number. Okay, that's a really big number, 48-digit number, and let's see, even with int64, which is the usual number data that you use to store integers, this can hold at maximum 2 to the 63rd power. That's the max number. This is the maximum number that this can hold, and this is less than 3 to the 100th power, right? So it's impossible for the computer, unless you use an extra package, to compute this and store it in its memory, because it's beyond the int64, which is the long integer that format that Python or other things can hold.
Wait, how do you go from 2 to the 48 to 8 to the 16?
Oh, right. So I was using 2 to the 48 is 2 to the 3 times 16. 3 times 16 is 48, is that right? Yeah.
Okay.
And then this is 8 to the 16th power. And we're using the fact that you can replace one number by another in the modular system. Okay. Now, you're not allowed to change 100 to another number, mod 7, because exponents don't work like that. But anything down here, that can be replaced one by the other. So, in other words, say 7 times 2 is 14. 14 plus 3 is 17, right? 17 mod 7 is 3. So if the question was changed to 17 to the 100th power divided by 7, you get the same answer, number 4. Because 17 and 3 are congruent under mod 7. That's what's going on.